This is the solution video for section 5.3, problem number 15. Coffee is draining from a conical filter into a cylindrical coffee pot at a rate of 10 cubic inches per minute. How fast is the level in the pot rising when the coffee in the cone is 5 inches deep? And then part B, how fast is the level in the cone falling at that moment? All right, so you're given a picture here, all right? Now, certain things are labeled, all right, but other things aren't, okay? So you see this cone-shaped filter, right, is draining into this cylindrical coffee pot, all right? Now, the cone, yes, is 6 inches in diameter and 6 inches tall, okay? But remember, the amount of water or coffee in the cone is not that 6 by 6. So remember, okay, that has a particular height to it and a particular radius to it. And so I'm going to refer to that as the R sub C, so radius of the cone. And then this is going to be an H sub C, right? So the height of the cone or the depth of the liquid in the cone, right? Now, those are both changing, right? Because as the coffee flows out, right, then that means that the radius is going to be decreasing and the height is going to be decreasing. So there is a dr sub c dt, right? And that is some negative value that we don't know. And then there is a dh sub c dt, which is also a negative value that we don't know, right? Now, there is a particular volume of water or coffee in the cone, all right? And so we could say there is a V sub C, right? And it is, of course, changing, right? So there is a dV sub C dt, which is, well, it says it's draining at a rate of 10 cubic inches per minute. So that is actually a negative number because that amount is decreasing. So negative 10, and then we would say inches cubed per minute, right? So that's dealing with the cone. All right, now we have to talk about the pot. All right, so the coffee pot. All right, it is 6 inches in diameter, which means that it is 3 inches in radius. Now, the radius is 3 inches all the time. It is not changing. No matter how deep the coffee in the pot is, the radius is always 3. So we do not need to give it a variable. However, there is a particular depth of coffee, which is changing, and so we have to call that H. I'm going to call it H sub P, and so since it's changing, there is a DH sub P dt, which is some positive value that we do not know, right? Why is it positive? Because as coffee flows into the pot, that height is increasing, right? It is the level of coffee is rising, all right? All right, then there is a particular volume of coffee in the pot, so V sub P, right? And of course, that is changing, and so that is dV sub P dt. Now, this is where some people kind of struggle. Okay, if the rate of change of the volume in the cone is negative 10 inches cubed per minute, all of that coffee that goes from the cone goes into the pot, and so that means the dV sub P dt is actually positive 10 inches cubed per minute, right? Because the volume of coffee in the pot is increasing, all right? So that's kind of all of the drawing parts. So now, A, right, it says, how fast is the level in the pot rising when the coffee in the cone is 5 inches deep? So we would say, find what, when, what? Well, find how fast is the level in the pot rising. So that means dH sub P dt. So dH sub P dt, right? That's what we want to know when what is true. Well, it says when the coffee in the cone is 5 inches deep. So that would be the H sub C equals 5, right? All right. So A is only asking really about the level of the pot. So how do we talk about the volume of a cylinder? So remember, the volume of a cylinder is found by taking the area of the base, which is a circle, so pi r sub p squared, pi r squared times h. Now, r sub p, I didn't write r sub p anywhere. Remember, 3 is the radius of the pot. That is not changing. So we actually put that in right away, 3 squared. So this would become 9 pi h. All right. So that is something that is important. We put in 3 because the radius of the pot is not changing. It is always the same. All right. And so here is the volume formula for the amount of coffee in the pot. And so what we're going to do is we're going to take the derivative, dV dt. Now, remember, this V, I should have written V sub P, V sub P, V sub P, I apologize. dV sub P dt equals, all right, 9 pi, that's a constant, times the derivative of H. Now, what is that? That's H sub P, isn't it? So what's the derivative of H sub P? It's dH sub P dt. So now, interestingly enough, okay, if I want to find, what do I want to find? dH sub P dt. So I'm just going to divide by 9 pi. So what is dV sub P dt? That's positive 10 equals 9 pi dH sub P dt. So dH sub P dt is equal to 10 over 9 pi. What are the units? Remember, the height is a linear measurement. So the linear measurements are in inches. So this would be in inches per minute. Now, we were told to find dH sub P dt when H sub C equals 5. Well, H sub C isn't even in this formula, so it's not relevant. All right, so that's A. All right, then we want to do B. How fast is the level in the cone falling at that moment? All right, well, at what moment? Well, at the moment when H sub C is 5. So we do need that, but we don't need it until part B. So find blank when blank. All right, so find what? So it says, how fast is the level in the cone falling? So we want to find dH sub C dt when H sub C is 5, right? So that's the same moment. All right, so how do we figure out how H sub C and H sub C, how are these related? So we're going to write a formula for the volume of the cone. So V sub C is equal to, remember this is a cone, so 1/3 pi r squared H. So pi r sub C squared H sub C. Okay, now just like some problems we've done earlier, we have r sub C and H sub C. We don't know r sub C or dr sub C dt, and so we want to substitute that out. So once again, we're going to use this similar triangle idea. So if I draw a similar triangle for the cone and then for the level of coffee, right? The radius of the cone is 3 inches, the height is 6, and so then we have r sub C and H sub C here. So what can we say? Well, we can say, I kind of ran out of room here, I'm sorry. We can say that R sub C is to 3 as H sub C is to 6, right? And so if I want to substitute R sub C, that just means that R sub C is equal to, if I multiply by 3, half of H sub C. So I'm going to go to my equation. V sub C is equal to 1/3 pi, and then instead of R sub C, I'm going to write half of H sub C quantity squared and then H sub C. All right, so now I'm going to simplify this, and then I'm ready to take the derivative. All right, so V sub C is equal to, now if this is 1/3 pi and then 1/2 squared, that's 1/4 times 1/3 is 1/12 pi times H sub C cubed. All right, now we're ready to take the derivative. What's the derivative of V sub C? It would be dV sub C dt equals, all right, now I've got the 1/12 pi. I'm going to multiply by 3, so 3/12 is 1/4 pi, and then H sub C squared, and then don't forget dH sub C dt. All right, so now what do I want to know? I want to know dH sub C dt when H sub C is 5. So I'm going to plug 5 in there, and then dV sub C dt is -10. So -10 equals 1/4 pi H sub C 5 squared dH sub C dt. And so now I just need to simplify and solve. All right, so I'm going to multiply by 4. So this would become -40. And then I'm going to divide by 25 pi. So 25 pi, all right, equals dH sub C dt. And if we simplify here, they're both divisible by 5. So this would become 8. This would become 5. So I get that dH sub C dt is equal to -8 over 5 pi. And remember, this is a linear measurement, so inches per minute.